So that's just, so from here I get 8 MB, okay? So disk capacity 8 MB, and even if you calculate this, 131,072 multiplied by 64. So that comes out to be 8388608 bytes, which is the same as 8 MB, okay? So the disk capacity is 8 megabytes here in this example. Okay?
Yeah.
All right. Any questions on this before I move forward?
No.
It's clear, right?
Yes.
Okay. So, question number 4. For the same disk, I mean this information is exactly the same as previous one. Okay. So for the same disk, I have a problem now. I want to store 10,000 records of 512 bytes each. What is the minimum, or there should be an N here. What is the minimum number of cylinders needed? Okay. So what do? I first find the file size. Okay. What is the file size that I need to save? I have 10,000 records multiplied by 512 bytes each. So that's 512 and then 4 zeros, so it's 5,120,000 bytes. Okay? That's the file I want to store. And now I want to know how many cylinders. So let's think of cylinder capacity. What is the cylinder capacity here? Yes, exactly, very good. It's track capacity multiplied by the number of surfaces. So track capacity is 128 multiplied by 256 because it's 128 sectors and each sector can hold 256 bytes. So that's track capacity multiplied by the number of surfaces, which is 4. And so this comes out to be this number 1310. What was it? 072. Okay, so that's cylinder capacity. So now how many cylinders are needed? How do I find that out? Number of cylinders needed. How do I find that out? I know that the file is this big, 5 million bytes, and one cylinder can hold only 131,000 bytes. So, how many cylinders? I will. Do I divide or multiply? Divide, yes. 512000. That's the total 5 sides divided by 131,072. This comes out to be This comes out to be 39.06 cylinders. So approximately you need 40 cylinders, okay? Approximately 40 cylinders are needed. Okay?
Yes.
All right, very good. Any questions?
No.
Okay, so now for the same disk, I'm asking another different question. This is actually about the speed. So the disk, we know that the disk spins at 7200 RPM. The average peak time is 5 milliseconds, and the transfer rate is 1 MB per second. I ask, what is the average rotational delay? How do I find rotational delay? Any idea? Okay, so what's the strategy to find rotational delay? Anyone remembers? So if we want to find rotational delay, we find the time that the disk takes to complete one full rotation. Okay? And then we divide that by 2 because we want the average, so the average time will be half of the time of one full rotation. Remember that? Right? So let's find the time for one full rotation. Where's my pen? Okay, so the disk does 7200 RPM. What does RPM mean? What is RPM?
Revolution per nanosecond.
No, M. Revolution per minute. Yes, very good. So this is revolutions per minute. So the disk does 7200 RPM in 1 second. Oh, sorry, no. The disk does 7200 rotations in 1 minute, right? That's given to us. This this means the disk does 7200 rotations in 60,000 millisecond, because 60,000 millisecond is the same as 1 minute, right? Okay. So 7200 rotations. Now what I want to do is, I want to find what is the time for one rotation. Yani one rotation is done in how many milliseconds. Now how can I find that? So the way to do that is that you want to convert this side to 1. Okay? You first look, my target is that there are 2 sides to this equation, this one and this one. So I want to make this 1. Now how do I make something 1? By adding or by dividing or by multiplying? By dividing, right? I can take 7200 and divide that by 7200 rotations. So that will be equal to 1 rotation, which is what I want. Okay? So, but whatever I do to this side, I have to do to that side also. So therefore, I will take 60,000, which is already on that side, and divide that by 72,000, right? Okay? So that's how many milliseconds it will take to complete one rotation, which comes out to be 8.3 milliseconds. So which means that in 8.3 milliseconds, one full circle will be completed, okay? Now, if that's the case, what is average rotational delay? Now, look, the disk is here, right? Let's say the head is here. Let's say this is the head. Now, if I want to read this sector, it will come very quickly under the head. If I want to read this sector, it will take long time to come under the head. So the average time for a sector to come under the head will be the time taken by half spin. Okay? So I just take this 8.3 millisecond and divide by 2. That's the average rotational delay. Average rotational delay is always the time of half a circle of the spin. Okay? So that's 4.15 milliseconds. Okay? Alright, so we got this done. Now, this is a good, interesting question. What is the average time to read one sector from the disk at a random location? So this time at a random location, so which means the head has to move and then it has to wait for the disk to spin. So this is equal to a product of 3 terms. What are those 3 terms? There will be 3 types of delay. What are those? The seek time, okay, the time to move the head, times the rotational delay, times the transfer time. Okay. So now I know what is average seek time. What is average seek time? that's which is 5 milliseconds,
Yeah.
right? Multiply by the average rotational delay. What is average rotational delay?
4.5.
We just found that out, 4.15 millisecond. Times, what is the transfer time to transfer one block? One sector, sorry. Okay, so this is something we have to compute.
Yeah.
Okay, so let's do that. Now I know what is told to me that the transfer rate is 1 MB per second, which means 1 million bytes, roughly 1 million bytes, because 1 MB is a bit different than 1 million, but roughly 1 million bytes are transferred in 1 second, which is 1 second is 1000 millisecond, right? 1 second is 1000 millisecond, right? So what I want to know is how much time will one sector need. So the question is this: 256 bytes are transferred in how many seconds? Okay? You understand the question? That will be the transfer time to read one sector. Okay, so now how do I do that? What calculation should I do? This question is the same as, by the way, let me give you an analogous question. You go and buy 20 water bottles for 5 riyal. Okay? Let's say for 5 riyal you get 20 water bottles. So I ask you, what is the price of one water bottle? Okay? This is the same. I'm saying 1000 bytes get transferred in 1 second. So how much time will it take to transfer 256 bytes?
Division.
Okay, so the easy way to do this is there are 2 steps here. Okay, first I convert this 1000 into 1. First I convert this 1 million into 1. So I say 1 million bytes get transferred in 1 second. So I divide 1 million by 1 million. Okay. But if I divide on this side, I have to divide on that side also. So this says 1 byte. 1 byte. So this is step number 1. I find the time for 1 byte, not 256 bytes because that's a bit difficult. So I find the time for 1 byte. So 1 byte will get transferred in 1000 milliseconds. That was already here. Divided by, because I divided by 1 million, I should divide by 1 million here also to keep the equation balanced, right?
Yeah.
So this is how much time it will take to transfer 1 byte. Sir? Okay. Now, but I want to transfer not 1 byte, I want to transfer 256 bytes. So how do I convert 1 to 256? I multiply by 256. 256 multiplied by 1 byte. Okay? We'll get, which is 256. 256 bytes will get transferred in. Because I multiplied by 256 here, I should multiply by 256 here also. So 256 multiplied by 1000 millisecond divided by 1 million millisecond, 1 million bytes. Oops, okay? So this is the time it will take to transfer 256 bytes, which is actually, if you calculate 3 zeros will cancel with 3 zeros, so it is 0.256 millisecond will be needed to transfer this many bytes, okay? And so this is my transfer time to transfer one sector. So I had here 5 millisecond seek time, 4.15 millisecond rotational delay, and then 0.256 millisecond to transfer one block. So the total time which is required is 5 multiplied by 4 multiplied by 0.256. So it comes out to be 5.12 milliseconds. Okay, yani 5.12 milliseconds will be needed to transfer one block. that clear? Are these two steps clear? Step number 1 and 2. Whenever you want to convert from one number to another, you first divide by that number. So the first step is division, so that you get to 1 unit, 1 byte. And then you multiply by how many bytes you need. And do the same operation on the other side. So this is a standard way, we call it unitary method in mathematics. This is a standard way to convert from one quantity to another. Okay? Okay, so remember this 5.12 millisecond. Let me clear the screen here. So I asked this question, what is the average time needed to read one sector from the disk at a random location? So we found out that it is 5.12 millisecond. Okay, now I'm asking what is the transfer rate in this? So what is a rate? Transfer rate means something per second. So look, what I have is, what does 512 millisecond means? What I have is 256 bytes will get transferred